Hello everyone, we're going to take a look at exercise 27 where we're going to take roots of fractions, for example at a, b and c, and at, for example, d and h. You also see how to do fractions when we have decimal numbers. And let's just take a look at how we can do this, and you will see me oftentimes using the same trick over and over again. For example, if I have the root of 9 over 25, I want you to remember that this is exactly the same as the root of 9 over the root of 25. And they're only going to give you examples where you then get roots which you can nicely calculate. For example, if there was root 5 here, then it wouldn't work. Here it works because root 9 is the same as 3 and root 25 is the same as 5. Remember, ask yourself which number times itself is the number inside the roots. That's how you calculate the roots. And you can just leave this in fractional notation. You don't have to convert this back to decimal notation or something. Okay? But what if we have a whole number in front of my fraction? Well, same rule apply, only now we're going to first convert this mixed number into an improper fraction. So instead of 2 1 over 4, I'm going to write this as one fraction. 2 is the same as 8 over 4, so a total of 9 over 4, which we should now recognize we could write as this, which is the same as root 9 is 3, root 4 is 2, and then convert back to a mixed number. It's 1.5. Okay, and some people see this mentally. They say, well, which number times itself is 2.25, and they know that that's 1.5. That works if you know it mentally, but if you don't know it mentally, there is a way to do it with a calculation. And at C, they try to make this more difficult, I guess, by just making the calculation longer. But this shouldn't pose any problem anymore. Do know that this is 8 times, right? So you get 8 times the root of 9 over the root of 64 plus, and you can do this in one step as well, right? So 7 is the same as 36 over 9, right? And you have 1 over 9, so in total you have 64 over 9. I immediately write it now down as the root of 64 over the root of 9. There's a terrible 4. Why does this work? Well, because root 9 is 3, root 64 is 8, root 64 is 8, root 9 is 3. Okay? And 8 times 3 is 24 divided by 3, this is 3, plus 8 over 3, which you could say same as 2 over 3. So the answer is 5, 2 over 3. Okay, so convert this to root 9 root 64. Root 9 is 3, root 64 is 8. Bring this into the fraction, make it an improper fraction. 64 9, root 64 is 8, root 9 is 3. 8 times 3 over 8 is the same as 3. If you have trouble with that, remember you can do it like this. 8 times 3 is 24. 1 times 8 is 8. 24 over 8 is 3. And then don't forget to convert this all back into one answer. With decimal numbers, the same thing. I want to make this a fraction, and the easiest way to make this a fraction is to write 0.36 as 36 divided by 100. And then you say, yeah, why does this work? Because, yeah, 36 is a number that I can calculate the root of. And 100 is also a number I can calculate the root of. Root 36 is 6. Root 100 is 10. So the answer here is 3 over 5. Or if you want to, you can write it as decimal notation. Right. Both work. I will always prefer fractions in this kind of calculation. So 3 over 5. Let's take a look at the other 4, and again they try to make this more difficult by making it longer, but this shouldn't scare you, right? Just follow the same step-by-step plan. 10 times. 1 is the same as 25 over 25 plus 11. So I have 36 over 25 minus a half times root 9 over root 100. So I get 10 times 6 over 5 minus a half times 3 over 10. 10 times 6 is 60 over 5. So this is 12 minus 1 times 3 is 3. 2 times 10 is 20, I guess. So the final result will be 11, 17 over 20. Let's check if we made a mistake. It's a weird answer, right? If you find a weird answer, see if you made a mistake. This is 25, 25, 36, 36 becomes 6, correct. 25 is 5, correct. 9, okay, 9 becomes 3, correct. 10, correct. 10 times 60 is 10 times 6 is 60 over 5 is 12. It's really correct. Minus half times numerator times numerator, 1 times 3, and denominator times denominator, 20. Yeah, this is the final result. It's a weird answer, but it's correct. Take a look at F. And this one you would say, oof, how can I do this one? Because 44 doesn't have a nice root, 99 doesn't have a nice root. Oftentimes what you then must do is see if you can divide the top and the bottom by a number in such a way that you then find numbers you can calculate. And remember, you can simplify this, because both the numerator and the denominator I can divide by 11. 44 divided by 11 is 4. 99 divided by 11 is 9. Yeah, and then this one, you can almost dream by now. This is 2 over 3. Okay, so if you can simplify, simplify first. And then at G, I think that you have to use the same trick. Minus 3 times minus 1 is a times, this is a minus. 1 over 75. First calculate. So first just do minus 3 times minus 1 over 75. Don't need that long of a thing here. Negative times negative is positive. So positive 3 over 75. Which again might scare you, but I can divide both the top and the bottom by 3. And yeah, if you want to, you can of course also just write down the answer in one go, right? You don't have to write down this intermediate step every time. The root of 1 is 1, the root of 25 is 5. And then at H we have to use the same trick we used at D. So first write this as a fraction if you find this difficult. Y, and again that's why it's important to know your squares up to 225, because then you know that this is actually a root you can calculate. It's 14, because 14 squared is 196. 14 over 10 is the same as 1.4, or if you prefer to, you can also here give the one answer as a fraction, 1/2 over 5. It's the same thing. Both would be correct here. Okay, so hopefully with those examples you now know what to do, and you should not be panicking when you find fractions or decimal numbers combined with roots. Good luck.